Hey, what's going on, everyone? We're going to continue on here with section 8.5 and moving right along with radicals. Now we're going to be multiplying and dividing radical expressions. One of the most awesome thing about mathematics is that mathematical concepts build. So we'll use a lot of the same concepts that we have been using from the previous sections, and you're going to see how they're going to be building. Heck yeah, building up our math skills so we can be nerdy. All right, so before we dive into section 8.5, I actually just want to do a little bit of review stuff that we learned from previous chapters. So let's see here. So back in chapter 5, you guys learned how to multiply two binomials. And I'll just make one up right here. Like you guys learned how to multiply 5x plus 3 and I don't know, 6x plus 1. Okay. And you probably learned it using either the FOIL method or the box method. Okay, so I'm just going to go ahead and use the FOIL method. Okay, and the FOIL method was the F stood for first, F-I-R-S-T. So we're going to multiply the first term. So if this is my binomial, because there are two terms, that's why it's called a binomial, I'm going to multiply my first term with my other first term of my binomial. So that's why the F comes in. I multiply those. So if I multiply 5 times 5, I get 30. And I multiply x times x, and I get x squared. Okay, so that's the F part. Now the O stood for outside. All right, so now we want to multiply the outside term. So that would be the 5x and the 1. Okay, so we did this first. Now we're going to go ahead and do the outside. That's what the O stands for. So 5x times 1 is a positive 5x. All right. I stands for inside. So now we want to multiply the inside term. So that's going to be the 3 and the 6. So let's multiply 3 and 6x. And that's going to give us 18x. And lastly, we're going to do the L, which is last. Okay, and that's why that's going to be the 3 and the 1. 3 times 1 is 3. Okay, so hopefully you learned that back in chapter 5, because we're going to use that now. And then, of course, you'd want to combine like terms here. So 30x squared plus 23x plus 3. And that would be the most simplified answer right there. Okay, so that's using FOIL. So we're going to be using FOIL here in just a few seconds. All right, and then the other thing that I want to review with you is when we are multiplying radicals. Okay, so just remember that if I had the square root of 5 times the square root of 5, okay, that means, okay, watch this now. That means I can, since they both are being multiplied and they have the same index, I can say that's the square root of 5 times 5, which is 25, right? Okay. And then the square root of 25 is 5. So really, the square root of 5 times square root of 5 is just 5. Okay. And if I had square root of 5 times square root of 6, okay, so they have the same index, so which means that I'm going to keep that same index of 2, but then they have a 5 and a 6 as the radicand. So I'll multiply 5 and 6 is 30, but we don't simplify 30 because none of our perfect square numbers goes into it. Let's just do one more here because we're really going to use these two properties a lot right now. Just want to go over them. If I had like 2 radical 2, not plus, times, actually we're multiplying right now. 2 radical 2 times, we'll do 3 radical, 6. Okay, and the way that you do that is you multiply first our coefficients, 2 and 3, so that's 6. And then, and now since they both have the same radicand, we're gonna keep it as a 2 right here, and then multiply 2 and 6, which is 12. Okay, but then we're gonna have to break down radical 12, right? So that's radical 4 times radical 3. So now that becomes 2 radical 3. Don't forget about our little 6 over there. So times 6. So actually this is really going to be 12 radical 3. Sorry there, I went a little fast, but just so if you can see there, we multiplied 2 and 6 and got our radical 12, and then we broke down radical 12 and getting this guy right here. Okay, so now let's actually start example number uno. All right, so we're going to be multiplying binomials, and they're going to be involving radical expressions. Again, binomial means the word bi, 2 terms. So see right here, 2 plus radical 3 is 2 terms. So that's why this is called a binomial. And then 1 plus radical 6 is a number or is another binomial. Actually, I think that's a 5 right there. Yeah, that's a 5. I'm just looking at my little note here. So let me just kind of go. There we go. That looks like a 5 now. Okay, so we're multiplying binomials. And they involve radical expressions. All right, so it's kind of neat to know what these terms mean. We're not just like, okay, multiply binomials. We're like, okay, whatever the heck that means. But you don't want to have the context of what this stuff means here. Okay, so if you notice now, it's a binomial, and we're multiplying. So just as we did in chapter 5, we can multiply these using FOIL. Oh, yeah, that's what I'm talking about. So let's do the thing, right? Let's do our first term. So 2 times 1. So 2 times 1 gives us 2. Now let's do our O. Let's do the outside term. 2 times radical 5. Okay. 2 times radical 5 is 2 radical 5. I mean, you don't do 2 times radical 5 is not radical 10, because both numbers have to be under the radical in order to put the product or your multiplication underneath the radical. Okay, so I just put the 2 on the outside and the radical 5 in the inside, and this just means 2 times radical 5. Now let's do the I inside. So now I'm going to go radical 3 times 1, which is just radical 3, and then L for last, radical 3 times radical 5, which is radical 15. Okay, so can we combine any terms? Well, we learned last section or two, I think it was last section, that the only time that we can add radicals together is that they have to have the same index, so the same little small number right here, and the same radicand. All right, and as you can see here, they don't have either of those. So really, this is the answer right here. There's nothing that we can simplify. Okay, going on to part B, we're going to do the same thing. We're going to go ahead and do the FOIL method again. Okay, so the first term, 4 times 4, which is 16. Now do the O, outside terms, 4 times a negative radical 5, which is a negative 4 radical 5. Let's do the I, the inside term, radical 5 times 4, plus 4 radical 5. Notice that when you multiply a constant number and a radical, the constant number goes first and then the radical. That's just the appropriate way of doing that. Lastly, do the L, which is radical 5 times radical 5. Well, it's positive radical 5 times a negative radical 5. And now watch this now. This is a negative radical 25, right? 5 times 5 is 25. Okay. Now notice this. These two terms right here, have the same index and the same radicand, which means that they're the same type of terms. So this is kind of like saying like negative 4x plus 4x. Just think of this as like some kind of variable. So negative 4 plus 4, those cancel out. So I'm left with just 16 minus 5, right? Because square root of 25 is just 5. And so we just get 11 then. All right. That's the way that one works right there. Let's move on then. And I don't know if you've seen this pattern now, but the FOIL pattern just goes, you take your first term and then multiply it by the first term and then second term, and then take your second term and multiply by the first and then the second. So it's kind of how that works there if you like the whole FOIL acronym. Or you're like, oh, look, I just do little arrow things. You know, that's cool. All right. So radical 13 minus 2, quantity squared. Well, let's see. This means binomial times binomial. Right? Remember, the squared means I take my base, which is the whole thing in parentheses, and I multiply it by itself. Okay? The common error is this. No! Here's the common error is students would do this. Radical 13 squared minus 2 squared. Okay? No! 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 Okay? You don't do this right here. No. We have to remember that the exponent tells us to take the base and you multiply it by itself this many times. So I'm taking the radical 13 minus 2 and multiplying it by itself twice. All right? So make sure you don't do that. No. All right. Now we're going to go ahead and do FOIL again. So let's do it again. Radical 13 times radical 13. Okay, I'm doing this right here. Is radical 169. Okay. Radical 13 times negative 2 is a negative 2 radical 13. Negative 2 times radical 13. Oops, see, I did this and then this. And now I'm doing this part. Negative 2 times radical 13 is a negative 2 radical 13. And negative 2 times negative 2 is a positive quattro. That is a 4. I'm trying to make it look like a 4. There you go. All right, cool. So we can simplify this guy to being just simply 13. All right, that's nice. Now let's check out this guy right here. Negative 2 radical 13 minus 2 radical 13. Okay, so say this is going to work here. Hold on, my little pen's not really working. Hold on here. Let me see if I get rid of that. No. Okay, there we go. Let's see where we at. Okay, so negative 2 radical 13 minus 2 radical 13. Well, I can combine those guys to be negative 4 radical 13. Okay, again, like you can think of this guy right here as like negative 2x minus 2x. If I said negative 2x minus 2x, isn't that just a negative 4x? Right? So that's the same thing right here. It's like a negative 4x, but our variable is radical 13. All right? And then we have a plus 4. So that means we can go ahead and combine the 13 and the 4. So we'll get 17 minus 4 radical 13. And we can't combine the 17 radical 13. All right, cool. And if that wasn't enough, I guess we have a part D and E here. All right, let's keep going here. Again, we're doing FOIL. FOIL all day long like it's cool. 4 times 4. Okay, we're going to do this first right here. The first, that's 16. Oh, now we got radical 3s. Oh, trickily. So we have 4 times a negative third root of 7, which is a negative 4 third root of 7. So we just did this. Now let's do roots, or third root of 7 times 4, which is a positive 4 third root of 7. And then lastly, do the last, which is a third root of 7 times a negative third root of 7. So that means that's a minus third root of 7 times 7 is 49. All right? Okay. So as we can see here, 16 is just 16. We have negative 4 third root of 7 plus 4 times the third root of 7. Well, those guys just cancel out because we have negative 4 plus 4. And we can bring this down, the third roots of 49. Okay, and if you're wondering, oh, well, can we break that down? Well, again, you look at all of your third powers, right? Like 2 to the power of 3, 3 to the power of 3, 4 to the power of 3, and so forth. Do any of those numbers go into 49? And if not, then we stop there, and none of them go into it. Last but not least, we have part E. So let's go ahead again and do FOIL. FOIL like it's cool. Radical R times radical R. So let's do the first. So that means, well, okay, watch this now. This is pretty cool. This is radical R squared, right? R times R is R squared. Oh. Now let's go ahead and do the O, the outside. So radical R times a negative radical S. That's a minus radical RS or SR. I mean, it doesn't matter which one you put first there. Let's do the I. So radical s times r plus radical SR. And lastly, radical s times a negative radical s is negative radical s squared. Watch how rad this is now. Check this out. Look at it. Isn't this right here? Isn't our index a 2? And we learned that this can, you always divide this number into that right there, right? So 2 goes into 2 one time. So really this is just r. It's just r right there. And another way that you can think about this is that the square root is the opposite of squaring. So really this square crosses out with that square root because they're opposite operations. They're just canceling each other out. And so that's why we're left with just r. Now we have a minus radical SR plus a 1 radical SR. So those are gone because they're the same thing. And look, we have a minus s because the square cancels out with the square root. Hiya. And we're done with the first example. Yeah.